Hello, everybody, and you're very welcome back to the next event in our All Island Innovation Programme for this year, which is being hosted today by UCC. Today, we're very grateful to have Professor Jim Browne of NUI Galway here to talk to us on the topic of Industry 4.0 and its implications for productivity and for the circular economy. Jim is the former Dean of Engineering and past president of NUI Galway. And he has written over 200 papers and 15 books on this area. I'm very grateful that Jim has agreed to talk to us today, and I look forward to his insights and experiences on this important topic. Jim, thanks again, and the floor is yours.
Thank you, Lawrence, and thank you all for participating in this seminar. It's a very short presentation on next generation industrial systems, talking primarily about Industry 4.0 and the move towards a circular economy. I guess if we were to look at what's happening in industry, we're looking at Industry 4.0 being a buzzword which has come into common use now. We're also seeing talk about a circular economy and decarbonisation, resource sustainment, etc. Let me start with Industry 4.0 and just give a small bit of background to it. Let me talk about Industry 1.0 and Industry 2.0 very, very quickly. Industry 1.0 was the 18th century. The technology enabler was steam power, and the innovation was essentially a belt-driven factory with a single source of power and power delivered through the factory from a central source via a series of belts. That was replaced in the late 19th century, early 20th century, by what we call Industry 2.0. The key enabler, the key technology, was electrical power. And the innovation was essentially the creation of flow shops, assembly lines, mass production, the realization of economies of scale. The opportunity effectively was to replace centralized power with distributed power, to put individual electrical machines on each production machine, each production line, which provided for a very much more flexible and a much greater opportunity for increasing productivity. However, and just to say this, that challenge to make that change was significant. And the early use of electrical power in those factories in the early part of the 20th century was in fact centralized electricity distributed throughout the factory. It was only about 10 years into that revolution that people realized it was better to have power at individual machines. The point I'm making here is that oftentimes when we go to bring in new technology, we try to replace old systems without relooking at the systems. And the issue really is that we need to understand that new technology offers new ways of working. And many times the new ways of working are as important as the technology itself. A final point to make on that Industry 1.2, Industry 1.0, 2.0 is to say that fundamentally there was a long delay as well in realizing the productivity gains. And that's often the case with new technology. If I go ahead now to Industry 3.0, which we're probably all familiar with, it happened within most of our lifetimes. It happened in the 1980s. And essentially there the technology was around electronic computation, the early computerized devices, the early devices based on software, robotics, CNC machines, automated QA. The innovation that technology provided for was flexibility in terms of manufacture and assembly, the efficient automation of small batch production, economies of scope now, and probably most importantly from a business point of view, the move towards order-driven as distinct from stock or forecast-driven production. And of course, much shorter life cycles, incremental improvements led by customers. So the disruption that it caused, I'm talking about Industry 3.0, the disruption was fundamentally around moving to order-driven manufacturing. In the case of consumer products, a move away from make to stock to make to order. In the case of capital goods, things like machine tools, for example, which I worked in many years ago, the move was from engineer to order to assemble to order. Now let's get to Industry 4.0. The technology here is much more sophisticated, and it's not a single technology. It's a set of technologies, all of which are maturing, converging, and interconnecting. These technologies include, for example, advanced sensors, artificial intelligence, machine intelligence, data analytics, Internet of Things, additive manufacturing, an interesting new process, essentially 3D printing, which has moved in recent years from rapid prototyping into production of small batches of very complex, very expensive parts in areas like aerospace, for example. Adaptive and collaborative robots, virtual reality, augmented reality, all driven by low-cost computing and interconnectivity, supported by mobile technology, cloud computing, and very, very importantly, low-latency 5G communications. That's a key point. The 5G revolution is really important because it provides the level of, if you like, of responsiveness on the internet, which allows the internet to be used for industrial applications. Some people call the 5G revolution the industrial internet, and that's not a bad way to put it. All this innovation is disruptive, and it's disruptive because of the convergence and integration of all these technologies in both products and processes. So we talk about smart products in an intelligent manufacturing system, or maybe even a product delivery system. Innovation is all pervasive across Industry 4.0. It impacts business processes. It impacts products in terms of customization and servitization. Servitization meaning essentially the replacement of physical products and the selling of physical products with the selling of a service in areas like, for example, photocopiers, elevators in buildings, printers. Lots of products nowadays are not sold as products. They're delivered as a service, and the customer pays on the basis of the service that is used. Innovation in manufacturing processes, I've already mentioned additive manufacturing and the circular economy. Let's look now at a very simplistic model of business processes. And this is simplistic. What it shows essentially is the classic value chain. Suppliers feeding into manufacturing, who in turn create or build and assemble products, go to distribution and on to customers. That sort of value chain was supported by four major business processes. One around product design, shown on the top. So co-design with suppliers is now possible. On the other side, customer involvement, customer-led design is possible. So you're seeing there the integration of product design with not just manufacturing, in the old design for manufacture, design for assembly business, but also with suppliers through co-design and with customers through customer-led design. And then on the bottom side of that diagram, you see the planning and control process. So that was traditionally supply chain management for suppliers and customer order fulfillment, including servitization on the customer side. Nowadays, that chain has also been joined up, and the ERP systems are handling the whole, if you like, order flow right from customer to distribution, through manufacturing, out to suppliers. All in all of those processes are now subject to major innovation. And if we look at those processes there, we can group them into two: design of products and customer-led design. We talk about CAD systems, computer-aided engineering systems, process planning systems, and other systems of that type, all integrated. We also talk about supply chain management, inbound logistics, customer order fulfillment and outbound logistics, supported by ERP, CRM systems, and so on. Those traditionally four processes are now merging into almost a single style process. And the opportunities for innovation across all of them are really quite startling. So the opportunities in terms of product design are product as service, which I've already spoken about, co-design with first-tier suppliers, and that may apply to SMEs who are involved in supply chains, who may have an opportunity to get involved in the design of the components or products that they are making for their OEM customer. Customer-led incremental innovation. A key point is the recognition that customers are often a great source of innovation. They're the product users, and they're the people who know what incremental changes would help in terms of their customer experience. In terms of process, the whole move towards customized production, software-driven, software-managed, efficient batch production, real-time data to enhance process control and equipment control indeed, increased use of facilities such as this through predictive maintenance and scheduling, all done through the internet, all done through software technology. Real-time embedded quality assurance as part of the manufacturing process, and also very importantly, the support or operator training using virtual reality and augmented reality. If I go beyond that and look at the supply chain area, the opportunities there are around building a relationship with suppliers. And again, as SMEs, you'll be aware of this, the importance of building a relationship with your customer. So shared scheduling, call off, etc. The notion of tiered suppliers, alternative suppliers, and end-to-end integration across the supply chain, the ability of the supplier to be part of the business process of the customer, in this case, the OEM. And of course, traceability through the supply chain in the case of products where traceability is required. Customer order fulfillment is now, it can be associated with product as service. It's essentially around relationships with customers. It's often nowadays through direct sales in the case of people, companies are making products as distinct from companies making components. It supports incremental innovation, and it allows for integration with customer order fulfillment and supply chain management, creating a single entity right across the chain from suppliers through manufacturer out to customers. And then beyond conventional manufacturing, Industry 4.0 also is seeking to involve itself in circular manufacturing and seeking to create a single solution to both. Circular manufacturing or circular economy is essentially around the manufacturer taking responsibility for end-of-life products, putting in place systems which allow for product take-back at end of life and for resource sustainment. A way of thinking about this is to look at the traditional manufacturing business model. That simply has a set of services. There's a design process, you acquire components, you have customer orders, you manufacture and assemble, you use them, service them, and then they're disposed of. In a sense, nobody thought about what happened post-use and post-service. The product was simply disposed of. The new model is what we call circular manufacturing. And that shows the addition of a whole series of processes, a whole series of subsystems which have to be put in place. Systems to support product retirement, to take back product, very complicated because we're now taking back from many customers to a single, if you like, supplier, as distinct from in the outbound logistics, which are one-to-many. One-to-many is far easier than many-to-one, as you can imagine. Product take-back, followed by assessment of the product, perhaps component assembly upgrade for reuse, perhaps reclamation of components, perhaps reclamation of materials, and then minimizing the environmental dispositioning and minimizing what has to go to landfill or has to be, if you like, disposed of. So fundamentally, we're talking about a manufacturing process which is, if you like, closed off in terms of the product cycle and the supplier taking responsibility for end of life and putting in place systems to dispose of end of life products in an environmentally friendly fashion. Another way of looking at that is in terms of the infrastructure required to support it. An infrastructure to support resource recovery from various customers, an infrastructure to support the product take back, like for assessing what comes back, infrastructure for reclaiming, an infrastructure, very importantly, to design for reuse, to design for reclamation, to design for end of life. Right now, we design products primarily with disposal in mind at end of life. We will need to move away from that. In essence, what we're looking at is a future industrial system where the volume of material which is reused is greatly increased, as distinct from today, where the majority of material at end of life is simply considered to be waste. We're talking about moving towards a quite different model, as is apparent from that little picture. That is easier, obviously, said than done. The concept is quite simple and quite clear. The reality is very, very different in terms of the challenge that it faces. And we talk about that challenge in terms of level or scale. We talk about the micro scale for individual companies or individual products, the meso scale for individual sectors or networks of companies, and the macro scale, which of course is the wider economy, city, region, nation, global, depending on the products we're talking about. And the circular economy will require, if you like, innovation at all three levels. And obviously all three have got to operate in sync. And there is some experience in this regard, which is maybe worth looking at for a moment. If we look at the European Union, they have identified a set of priority waste streams. And those are listed there in front of you: electronics, batteries, packaging, plastics, textiles, construction, food, water, and nutrients. Now, in fact, the union started over 20 years ago with waste from electronic and electrical products. They have done very little since, to be very frank with you, but they're now in the new Green Deal for Europe are now upping their game in terms of these different waste streams, and they have published this group of waste streams that they want to deal with. And their approach at the European Union level, if you like, at a macro level, is to identify the barriers to the expansion of markets for circular products and the means to address them. That's what they've learned based on the experience in electrical and electronic products. And maybe just have a word about that for a moment, just to say what that experience was. That is based on the so-called WEEE directive, Waste from Electrical and Electronic Equipment. That was put in place in the early 2000s. It was updated in 2012. There's now equivalent legislation in China, in Japan, in California. And it was the first part of the European Union circular economy package. Fundamentally, it was based on a hierarchy of waste, talking about prevention by good design, reuse, including repair, recycling of components as subassemblies, recovery in terms of both toxic materials for dispositioning and valuable materials or scarce materials, and then finally disposal being the fallback position, which should be minimized. The experience has not been good with that directive. If you look back now, we see the volume of e-waste worldwide every year is about 45 million tons. It's highly variable by country. The European average is about 16.6 kilograms per person per year. And that goes up as far as 70 in some countries and down to 7 or 8 in other countries. In Europe, approximately half of waste was collected for the last year that I've seen statistics, 2016. And that was collected, but it wasn't really dealt with very well. Collection is low because of incorrect disposal. As I said, a huge range of fast-changing products, inadequate infrastructure, but at municipal and if you like, industrial level. The challenge of reverse logistics is underestimated. Take back, if you like, the many products coming back to a single source is difficult. The economic model is not clear who pays for it. And this whole notion, on the positive side, there are kind of two changes that maybe are positive in terms of electronic waste. One is servitization, which has certainly taken place. For example, you think about 20 years ago, we would have bought CDs, we would have bought records. Now we download music onto our iPhone. So in a sense, we've replaced a product with a service. So servitization has cleared the decks in terms of CDs are concerned. So this kind of model of similarly videos have gone. So this is the example, if you like, of the servitization helping electronic waste. But in general, the experience has not been good. What we have seen in that is that we have minimal reuse, minimal component recycling, very, very little of it. A lot of resource recovery, insofar as it exists at all, has been around shredding, mechanical shredding, and destructive shredding of products. We've had limited safe disposal, limited recovery of toxic materials, for example, flame retardants, leads, magnesium, cadmium, limited recovery of expensive parts, copper, gold, aluminium, silver, Also, there's a separation of capital goods and consumer goods. The experience is that capital goods, electronic capital goods, I mentioned photocopiers, for example, which are now highly electronically oriented. The numbers there are very good because the servitization model is easier to manage. There isn't the same take back that the supplier retains ownership of the product. But for the majority of electronic products, it has not been good. And the challenges, as I said, are really at the level of, as I've spoken there about, in terms of recovery itself. But prior to that, at a higher level, there hasn't been sufficient work done on eco-design or design for reuse. There's been very limited repair opportunity put in place. There has been very, if you like, erratic customer behavior. And the fundamental underlying model is not clear in terms of the economy, who pays for it and why. I say all that because I think we have to recognize that the challenges going forward for circular economy are much bigger than any individual firm. As I said, they exist at country level, global level, country level, industry level, company level. They're not going to be solved quickly. However, what I will say to you is that, you know, the European Union seems to have, if you like, found its mojo around circular manufacturing, circular economy. It seemed to have lost the initiative up until recently. Perhaps it was overconsumed with Brexit and overconsumed with expansion and so on. Politically, it went through a very difficult period over the last 10, 15 years. So there hasn't been as much progress as there might have been. But my suspicion is that now there is a clear commitment at European Union level to move towards circular manufacturing for reasons of decarbonisation and also for reasons of resource sustainment. We know that that materials are in short supply. We know that there are rare earth metals, particularly in electronics, which are very expensive and are worth recovering. We know that there's a possibility, if you like, of creating a much more sustainable world through a circular economy, if we can only build, if I can get to do it. My expectation is that that's what will happen. So let me try to conclude this relatively short and very quick run through Industry 4.0, looking at the future. The future is fundamentally around digitization and circular manufacturing. In many ways, Industry 4.0, if you like, light is digitization. It's about the use of technology, and it's about the use of internet technology, 5G, and all those merging technologies I mentioned earlier, additive manufacturing, etc. All of those, but it's also about circular manufacturing. And the good news is that the technology, in fact, supports circular manufacturing. If I think particularly of high-value goods, these days it is possible to build into those products the intelligence to capture data on the product itself, to have information available on a memory chip with the product, which identifies what's in it, what materials are where, what materials could be salvaged, and that we also collects data on the product as it's used. So at end of life, that can be interrogated, and that can allow the recycler, the entity which is dealing with the end of life product, to interrogate that and get a sense of what the product is about and deal with it. So that the technology supports it. The technology which essentially supports digitization also supports circular manufacturing. So we're talking fundamentally about a kind of a cyber physical production system where we have smart products, that is products who carry with them information about themselves and about their own use and about their service. In some, we're talking about digital twins of products. We're talking about the product, if you like, being captured digitally as it's been developed and as it's been built. We're talking about digital twins of production systems with advanced simulation capability, which will allow us to create a true cyber physical production system. And arguably, and I maybe conclude on this, additive manufacturing is probably the best example I can think of a cyber physical system. In additive manufacturing, we go directly from the digital model to the physical product. We simply download the digital model onto a 3D printing machine, and we produce the physical product from it. In many ways, the reality of additive manufacturing gives a sense of what the future is going to be in terms of digitization, but also in terms of the wider economy. So with those, I would maybe leave it at that, and thank you for your attention. Thank you.
Thanks very much, Jim. That was a wide-ranging and excellent talk. Can I ask you a couple of questions, just given that the audience is virtual here? I'll put on my SME hat. You know, given that SMEs, one of their greatest challenges is competing against economies that have economies of, or against competitors that have economies of scale and are much larger, does Industry 4.0 and the movement towards mass customization, is that an opportunity for them, do you believe?
I believe it is, because one thing I did not mention in that process was that we're also talking about the possibility of distributing manufacturing. If I take, for example, a technology like additive manufacturing, that technology can be put anywhere, and the production process can be put anywhere, and the if you like, the design, the manufacturing instructions can be downloaded to it from anywhere. So that means that if one is close to customer, as an SME, close to physically close to customer, one can create the product right beside the customer. But in general terms, the availability of manufacturing instructions and product instructions on the web makes it available to everybody, irrespective of their location. So that's, to me, that's a very important aspect. The other thing I would say to you is that the notion of if you like, mass customization speaks to low volumes, which suits SMEs. And in an environment where we have the technology now to allow for low volume, efficient production, SMEs have the opportunity. I agree that technology is capital intensive, and that can be an issue. But fundamentally, I think that the availability of the design, the manufacturing instructions on the web, the availability of the possibility of downloading to individual machines to manufacture, And the fact of small volume production, small batch production, because of mass customization, I think creates opportunities for distributed manufacturing, in other words, for SMEs, much more so than the past, in my opinion. But I would warn that it is capital intensive.
Yeah, and that was kind of my worry. Is this a barrier to entry, or is it an opportunity for the SME going forward in relation to Industry 4.0?
I think it's an opportunity. I think it's an opportunity, but there are challenges. Let's be clear about that. No opportunity comes free.
Yeah,
but the opportunity is there.
In relation to the circular economy, Jim, and I know you've been doing a lot of work going back to the 80s and 90s, even on end of life. The circular economy, is it from an industry perspective rather than society, is it going to be a regulatory push, do you believe, or is it going to be a kind of a market pull or a mixture of both?
I think it's a combination of both. I think that customers are demanding it. I think customers are demanding that producers put in place systems. There's no doubt that we see customers are looking for it. There are customers who are arguing for in the case, for example, simple things like coffee cups. People want biodegradable cups, and they're willing to pay a little bit extra for them. There's customers. If I look at people like IKEA and the furniture people, they have made an issue. They have gone to the trouble of designing their products for disassembly now, because they recognized, I presume there's an element of good engineering about it in terms of resource stint, but it's also a reality in the marketplace about it. So I believe it's a combination of the two. And I would also say to you, look at what's happening with investments. Look at what's happening in terms of ethically sourced investments, and look at all the money that's now going into companies who are determined to meet high standards around resource sustainment and around clean manufacturing and around green economy. So I would say it's a combination of the investors, it's the producers, it's the consumers. All of them, I think, are moving in the same direction.
Okay, thank you very much. One last question, Jim. If you're an SME manager and you're saying, yes, there is an opportunity here for me in Industry 4.0, where should they go next? Where is the best source? Is it Enterprise Ireland? Is it Intertrade? Where should they go to, or is it the universities to access? What's the first steps?
I think it's all three. I think Intertrade have a clear role to play. So do the universities. There are research centres in the universities. And there are also technology centres. There are research centres which perhaps are more medium to long term, funded by SFI, but there are also technology centres funded by Enterprise Ireland, which are closer to market, if you like. I would avail of all those opportunities. I think they're all good. Industry 4.0 is total digital integration. Vertically, design, manufacture, and operations. Horizontally, customer and supply chain. Through the product life cycle. That's important as well. So it's in time as well as through those processes. And it's enabled by 5G, the industrial internet. Maybe one last comment then. Technology forecasts, and that's what we're talking about here, technology forecasts. We're talking about what the future might look like, Industry 4.0, circular manufacturing. In general terms, if we look at technology forecasts, we tend to overestimate short term, but to underestimate medium to long term. So I would say to people, think about that. Some of what I'm talking about may sound very futuristic, but in general, and that is probably anybody who's in the business of trying to look forward, often tends to overestimate in the short term, but longer term, medium term, we tend to underestimate. Thank you. Thank you very much.
Thank you again, Jim. I especially thank you for highlighting the areas where SMEs can go to seek support in this important area, like the Intertrade Ireland website. Thanks again, and thanks to our community for tuning in today, and look forward to having you at our next event again soon.